The first thing that we're going to learn about today is the dot product. To find a dot product of two vectors, what you do is u1 times uv. In other words, the x coordinates multiplied together plus u2 times v2. In other words, the y coordinates multiplied together. So really, next we'll talk about properties of the dot product. A lot of the properties will look similar to algebraic properties that you may remember before. For example, u dot v equals v dot u. Now that might remind you of algebra, where it doesn't matter what order you multiply things in. Or, number 3, 0 times a vector is equal to 0. In the property number 4, you notice that the dot product is distributive. So u dot v plus w, you can distribute u dot v plus u dot w. In number 5, it also doesn't matter which order you do things in if you're multiplying by a scalar number, just a number by itself. The kind of unusual one is number 2. The dot product of a vector in itself is equal to its magnitude squared. We're going to use that product in example number 2. Example 2 says, use the dot product to find the length of vector u if vector u is 4, negative 3. We'll use the property number 2 by finding the dot product to find our magnitude. To find the dot product, we'll multiply the x's together. So 4 times 4 would be 16, plus multiplying the y's together, negative 3 times negative 3, which is 9. Following proper number 2, u dot u equals the magnitude squared. So this is going to be the magnitude of u squared. 16 plus 9 is 25. So to find the magnitude, we need to get rid of the squaring part by taking the square root of both sides. So the magnitude of u would be 5.